So for project 2, I hosted a fully managed Kubernetes cluster using AWS EKS service. So the agenda for this is to go over the goal of the projects, the services used, give a demo of the integrated features in EKS, and also state any problems that I faced. The goal of this project is to explore the Amazon Elastic Kubernetes service with integrations of features such as Elastic Load Balancer, IAM authentication, and as well as logging with AWS CloudTrail. So I'm just going to go over a brief overview of the services that I integrated with. Two of them were required. So the first one that was required is the IAM service, and for that I needed an existing EKS cluster role. And as you know, IAM stands for Identity Access Management. It's a web service that allows that helps you control access to your AWS resources. The second feature that was a prerequisite was a VPC, and that stands for Virtual Private Cloud. And this just will give us full control over the virtual networking environment. And I needed a VPC with specific requirements of an EKS cluster that I got off the Amazon documentation. And after those two things were deployed, I was able to deploy the EKS service. And as stated before, EKS stands for Elastic Kubernetes Service. It is a managed container service to run and scale Kubernetes applications in the cloud. After that was created, I was able to create worker nodes with the EC2 instances. EC2, as we've used thoroughly throughout the class, stands for Elastic Cloud Compute. It allows for instances to spin up on demand if we need it, if we need more capacity. Also, I was using CloudFormation. I actually used CloudFormation to deploy the VPC with the JSON file that they provided. And I also use CloudTrail to monitor and record account activity across AWS Infra, and that was already integrated. All I have to do is turn that on, and it's integrated automatically with EKS services. So now I will go over a demo of the integrated features in EKS. So before we even created the EKS cluster, I had to do two things beforehand. One was creating a virtual private cloud. I actually created this virtual private cloud through CloudFormation, which is, again, the template service. You can see that I have a stack here called EKS Cluster East because I deployed it in the East 1 region, US East 1 region. You can see that if I look at the resources here, it created a virtual private cloud, public subnets, private subnets, public routing tables, blah, 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 all these things. And it connected everything properly. It looked pretty good. So I actually was able to deploy this through a JSON file that I found through the AWS documentation. So if you look at the template, this is what I deployed to get the stack. If I view it in Designer, you're able to see how all the components are interacting with each other. After this was deployed, I was able to view this. I was able to view the EKS cluster, the virtual private cloud that it created. Nothing was really needed to be done on top of this. The JSON file is pretty inclusive and is pretty complete. So after I created the virtual private cloud, I had to create the IAM role, the dedicated IAM role. So you can see here that I created an EKS cluster role. It allows access to other AWS service resources that are required to operate cluster managed by EKS. So you can see that there's a permission policy attached to this and also a trust relationship. The permission policy it provides admin access to do everything to create the Kubernetes cluster. And then the trust relationship, it will allow whoever is deploying it to assume this role under like the conditions specified here. After these two items were deployed, I was able to go through the AWS console and create a cluster. I just hit create and I went through the steps here. After that, it took a little bit of time to come up, but then I was able to get an EKS cluster in the East region. as you can see, right now I have 2 nodes connected to it. They're part of this thing called node group, which is a group where it's like an auto scale group that can scale nodes based on the capacity. So let me quickly show you that. If I go to compute node group, if I click on node group, you can see that I have a minimum size. It has an auto scale group name. Also, the nodes are able to deploy on any of these subnets, which is in the North Virginia, so US East 1 region. I have the instance type is T3 small, and also the AMI type is some like Linux L64 stuff. So as you can see here, oh yeah, let me show you again. So the minimum size is 2 nodes. So the minimum size of the cluster that it can scale to is 2 nodes. The maximum size, say if there's more capacity, I need more capacity, it can scale to 4 nodes. And the desired size is the size that when I create the node group, how it's going to just spin up with like that many nodes. And likewise, I can change any of these parameters. If I just go here, I can change this to 5, change this to 3. If I think I need more capacity, all these things. I think if I was using this Kubernetes cluster in like a more, if I needed for like batch jobs or something, I would just set the max cluster size to a larger number just to allocate for more resources there. Let me just cancel these changes. Okay. So before I move on to showing the sample application, I just wanted to go over the CloudTrail and how EC2 is actually integrated. So you can see that there's 2 nodes right now inside this cluster. There's 2 node group names, these 2. If I go to the EC2 instance, or EC2 management console, let me switch the region to North Virginia. You can see that I have 2 instances running. These instances are the same instances as shown here. So if I click on this, you can see that the instance name, this ends in 4C79, and 4C79 exist here. So we know that these 2 instances are connected. If I click on it, you can see that it's directly on the virtual private cloud because we created through that node group. It has an assigned IAM role, so to create node groups, I needed an Amazon EKS node role. This is just so it separates everything and it doesn't allow the nodes to do anything that they're not able to do. And yeah, this is just like general thing. We never really have to like look into the instances because they're managed by the EKS service. Yeah, okay, then after the EKS service comes up, I just like turned on CloudTrail. So CloudTrail, like I said, it's just for audit logging. So if I look here and go to trail, there's one trail that's on. It's just for management. You have to be in the same region for this to just pick up everything. You can see that logging is enabled. I have a log location. This is an S3 location. Let me open it. CloudTrail, US East 1, blah, blah, blah. Let me just click on a random one. So you can see that there's a bunch of like JSON files that are zipped up inside of S3. So if I ever downloaded one of them, and I did that beforehand, let me just pull it up. I'm not really able to like read a bunch of this, but I did pick out one that was kind of important. So if you look here on this like log that I singled out, it shows like anything that to do with cluster. It's logged here. So I must have done something with auto scaling. Maybe like I was scaling a node group or something, and it showed up in these logs. So, and it also, yeah, so it has like the instance ID, and it also, basically they can track me like for anything that I do. Go over a sample application that I deployed and any issues that I faced during it. So a prerequisite for deploying the EKS service was having AWS CLI already installed on your machine. So I did have to install that. But after I installed it, I was able to connect to the Kubernetes cluster by running kubectl get nodes. By the way, I also had to set up like a kube config. I wasn't just able to like run that command. I had to set up like a configuration file that connected, that was configured in my AWS account to connect to these nodes. But anyways, you can see that there's 2 nodes here, and these nodes match up with the node names from the node group, which is nice. You also might notice that there's no manager nodes. The manager nodes are maintained by the EKS service. I do not touch them, which is pretty nice because we only need to like worry about the worker nodes now. So now let me show the pods. Pod get A. And -A stands for all namespaces. So you can see that there's a few namespaces here, but the namespace that's most important is this kube system namespace. This has all the administrative configuration files, or all the administration deployments and pods. So a lot of these did come pre-installed with EKS as soon as I booted it up, but I want to take a little note to this AWS load balancer controller. So this the AWS load balance controller is a controller to help manage elastic load balancing for the K8s cluster. And this will just allow my pods, when I connect to this controller, it will allow it to connect to the EC2 instance. It would connect to the AWS console and deploy EC2 instances and like load balance between that. And now I want to show the game or the application that I tried to install. So I tried to install a game called 2048. It's just like a simple web application game. I found the configuration files online. This game, it's pretty simple. It just has a deployment, a service, and then an ingress to go on top of that. So if I show the pods, oh, by the way, I put an alias, so I did not have to type kubectl every time. Get pod. You can see that there's 5 pods here. They're connected to a deployment. Okay, cool. And then get svc. Oops, sorry. So there are 3 components that I deployed to get this application deployed, at least. One was a deployment. This deployment controls how many pods can spin up, so you can see that it has a replica of 5, and you can count there's 5 pods here. And then behind that, it's connected to a service, and the service just exposes a port and allows my ingress to connect to that port and display over the internet. So you can see that my ingress, which is just basically a load balancer for Kubernetes, it did generate an address, but when I go to that address, I'm getting this 503 service temporary unavailable. I think it has to do with how I set up the configuration files. I did look into this error. It said that I can try to restart the nodes, but I tried to do that and it didn't work. But what I did find interesting was that in the EC2 management console, I was able to see the load balancer that it created here. So it did create a load balancer. It was able to communicate to the AWS cluster and generate this. It just has a service temporary unavailable. I wonder if I sent something up wrong or I didn't configure something properly. Yeah, so that's where I got stuck with that. It's just I was getting the 503 service temporary unavailable. If I have some more time, I will look into it a little bit more. I know we're running a little short on time, but I just did want to go over the 2 problems that I faced. So the first problem was that I realized that IAM roles do not equate to the IAM policies. The IAM roles manage who has access to the AWS resource, while the IAM policies control their permissions. And then the second issue that I faced was the service temporary unavailable. I'm trying to investigate that as right now. Thank you for listening to what I did for Project 2.